I know everybody's very busy, if it's morning, evening, or afternoon there, wherever you are. So today we're going to be talking about deploying stateful applications in a Microsoft AKS cluster using OnDat. And just about to dive in, we're going to talk a bit about me and my background. So my name is Rodney Karemba, and I'm a solutions architect at OnDat. I've been working at OnDat for about 6 months. So I started last year in November. And I generally work with the customer service team, and my goal is to help customers, run safer applications at scale in Kubernetes. Background experience, I came from a Kubernetes background and Linux background too. So worked prior, I was at Canonical, and then StackRox, and then a little bit and then also worked at Apple Security. But I've been helping a lot of customers, work with Kubernetes and and solve the cloud native challenges. Feel free to reach out to me. This is my email address if you have any other further questions after this webinar. I'm also at KubeCon, so if you are available around at KubeCon, feel free to come over to the booth and say hi, and we can get to talk a bit more about OnDat and everything Kubernetes. Today's agenda, we're going to be talking about a bit of OnDat and architecture. And we're going to do a deployment to a demonstration specifically of OnDat and AKS. That'll be somewhat of a live demonstration. So fingers crossed the demo gods will be with us. And we're going to be doing a demo just to show how to create an encrypted, replicated, and performant persistent volumes for state workloads. And we're going to deploy step application and Q&A at the end. All right. How did you get here? So prior to this, you can see how storage has evolved from being from a server to being in a hypervisor. And now, as we are where we are today, is Kubernetes, and how do we solve the storage issue in Kubernetes? I think they're probably like two or three of the main things that are probably like hard things to solve in Kubernetes at the moment, which is storage. I think networking is also a bit of a challenge, and secret/security is also kind of the main issue that kind of should be kind of like one of the things that should be solved. This is OnDat, and this is OnDat's key features and how we approach cloud native storage. OnDat is a Kubernetes native solution, and the whole point is to provide self-service storage. We are a performance solution. We understand performance is very important for your application workloads. Applications need to be scalable, and so does your data too. And high availability, we ensure that we have cross-node volume replication. One of the main things also is to reduce cost, right, of storing that data, or even utilizing storage, right? That's one thing OnDat also achieves very well. But also, most importantly, we want to make sure that we are able to free your data. So to be able to run any of your stateful applications anywhere on any different Kubernetes provider that is Kubernetes compliant or certified specifically. And lastly, I think we talked about security earlier on, and we provide encryption at data at rest and in transit. Just to dive a bit more into a technical overview of the components for OnDat. You can see here that we have OnDat nodes, and these are essentially these are pods deployed as a daemon set. These will be the ones that will pull all the storage from your block devices that are attached to your worker nodes in your cluster. From then on, we have other components of the API manager, the operator, the scheduler, the CSI helper. And of course, this will help us to be able to manage all of our volumes and make sure that our OnDat instance is healthy. And I think another thing that's also quite important, we also have we're also able to deploy a separate dedicated etcd instance inside Kubernetes, and this acts as a backing store for OnDat, and ensures that our configurations, the state of our cluster, and the volumes is consistent. As of course, making sure our data is consistent is key. And yeah, so this is a bit of an overview of how OnDat works. And to the right hand side, you can see some of the ports and the protocols that OnDat uses. And these are between nodes. And yeah, that is pretty much of an overview of OnDat here. But we're going to dive into a bit more of some of the use cases that we'll talk about in the demo later on. And one of the things is replication for data protection and high availability. And the goal for replication here is to protect data from transient node failures and ensure a strong consistency for stateful applications. Our replication is synchronous between the master volume and its number of user-defined replica volumes. Replica volumes can be from 0 to 5. But of course, if you add more, you might want to be considered about the performance. But on average, we generally recommend 1 or 2, 2 if you wanted to achieve high availability. And here are kind of the flows in terms of how you're able to, how our application feature works. So data from the application is written to the master volume first. Then data is then written in parallel to the replica volumes. Master and replica volumes all acknowledge that data that has been received and written, and then a successful write operation is returned to the application. We use a delta sync algorithm between the volumes, and this means that if a replica volume goes offline and comes back online, only the regions with the change blocks needs to be synchronized. So this reduces the time it takes for replicas to catch up and improves volume resilience. So you're not waiting for a new volume you created. It's pretty much based on transactional change that when made, and this makes it much more faster to recover. And on top of this, we also released this feature on that 2.5. This was, I believe, a couple of last year or so, topology awareness placement. And what this does, this enforces that volume placement across different failure domains or zones to guarantee high availability. So if you want to make sure that you have high availability for your data on each different node, we can enforce that and make sure that is possible. One of our customers is actually using that at the moment, and they did a test where they just dropped the zone and it came back up, and everything worked with no issues, and that was thanks to the tap feature that we have developed. The next thing here, we have data encryption at rest. I don't want to go into detail here about some of the security aspects of storing data at rest. Security is a big thing. I come up with a security background, and I believe that it is important not only for your application to be secure, but your application data to be secure too. So one of the things here is that we support encrypting data at rest, and we do this by simply enabling a Kubernetes label. We call it a feature label, but it's just a Kubernetes label, and you can define that by storageos.com, encryption equals true. You can define that in your storage class or your persistent volume claim definition / manifest before you provision those volumes that you would like. Data stored under the nodes varlib storage OS data directory as blob files, and of course it'll be encrypted, so it'll be just a gibberish if you try to read that information without the encryption keys. Volumes are encrypted using AES 256 in the XTS AES mode with 512-bit keys. There is a non-zero performance impact using encrypted volumes. But depending on the application you're running, right, and depending on the workload and the usage, there is a 10 to 25% cost. As with everything with security and encryption, there is always a slight cost, but here it's not much of a significant difference, but it also depends on the application that you're using. And thin provision still applies to encrypted volumes too here. And performance is another important thing here. And this is one thing as on that we excel at. And here, this is some of the this was an independent study that took place last year, around March 2021. This was just doing a comparison between other storage solutions out there, and in terms of how we perform on an IOPS level. That's including a local volume and a replica. On that is to your left hand side. Larger values means that it's a better performance. And if we go to the latency aspect, lower is better. We strive to make sure that we have low latency for our data, and this is another key thing here. We have throughput and bandwidth. So left hand side here again, where larger values are better. Feel free to go ahead to the links here that I've provided here, that are the sources. And there is also a deep dive into each. I believe there's a PDF that shows a deep dive into each comparison benchmarks. But I just pull these out just to give you a quick overview as to how OnDat performs from last year. And I believe we are working on another one this year. As OnDat has improved ever since this was released, so we should be hopefully expecting better performance numbers. Cool. And how do we? So we're talking about OnDat features here, but we want to make sure that we enable the developer to create their applications without any hassle or without any friction. And we can achieve this, of course, as I mentioned earlier on, using Kubernetes labels. And you can simply just specify one replica and encryption to true and topology awareness in your persistence volume claim. And then, of course, you can attach that to your pod that requires storage, and we automatically provision all of these features for you. And this is the most important thing, is that we want to make it Kubernetes native, and we want to make it very simple for developers to use. As people should be focused on delivering the business value rather than trying to over engineer specific things. So keeping it simple is always the most ideal way of doing things. And for platform owners, SREs, here we can define a storage class through storage class parameters, and you can almost do the exact same as what you're doing before, but here it will be pretty much as a storage class. And you could also set it as a system-wide storage class, so that any application that is going to be requiring any storage, any block storage, you'll be able to it'll always pull from this definition here that is creating the storage class. So the goal here is, you can see it's very similar and it's still very simple. There's no need to go and configure any other encryption parameters. It is just one flag for each feature, and I think that's the goal, to provide the self-service aspect of creating software. Cool. So we're gonna go to a demonstration now, and I did mention earlier on that it's going to be a live demo, but before we do start there, I'm just gonna go over in terms of how you can easily get started on that. You can download the kubectl Storage OS plugin here, and you can deploy on that to an AKS cluster, and then on that will automatically pull the block storage available that is attached to the nodes. For this demonstration, you can go to this Git repository here. I'll be using Terraform, and essentially this Terraform manifest and /configuration files will install on that automatically, and also create an AKS cluster too automatically for us. But the secret sauce here is that I've already created a cluster, because we are a bit tight on time, and depending on your the bottlenecks of the cloud provider that we're using, or the availability reason, I didn't want to kind of take risks, as it probably may take 20 minutes. Sometimes it takes 3 minutes, but it all depends on which region and how many resources available. But yeah, and there you go. I mean, if you can see, the third command here is installing OnDat. include etcd. That is the installing the etcd cluster inside your Kubernetes cluster, and your username and password, you can define it as how you want it to be. And then once it's installed, it only takes about 1 or 2 minutes. And then afterwards, you're able to inspect the pods and make sure that they're in a running state and get started on that. So we're gonna go straight to the repository here, and you can see we've got a couple of Terraform files here and a README that I wrote about a while back. I've been making a couple of changes to make sure that the versions are pinned, and a couple of variables I've been working, trying to make it a little more simpler. One of the things here is I've explained here some in terms of what each file is. We've got the data sources. We've got the main configuration, main.tf, which allows us to provision an AKS cluster. I also added a little bit of monitoring there that uses Azure Log Analytics, just to get a bit of an overview of the health of the cluster as you're running it. And the outputs, if you want to reuse those values that are completed from the cluster. You've got variables here that allows you to make it much more further customizations rather than making them static instead. And the versions, of course, your providers, your modules that you're using. And cool. You can see here, of course, we've got the dependencies. This is all open source, it's accessible. So if you want to go ahead and create this in your own time, feel free to go ahead and do that. And we're going to go here first. Go to the main, can show you what we're creating. You can see we've got the resource group here, and we've got the managed Azure Kubernetes service. And you can see that these are the variables we're talking about. These pretty much just define a node pool, a default node pool. That's a 3 nodes, the 3 nodes. And then afterwards, we have a node pool that's called storage, and that will essentially create an extra 2 more nodes. And that is pretty much it. And we've got a local file that generates a kubeconfig file. And you can see here, install on that. I think the command I showed you earlier on, I did have a bit more values here. I just wanted a bit more configurable and customizable. But you can see that's the storage class here, and username and password, all variable based. And that is pretty much it. So let's go straight to our terminal. And if I scroll all the way to the top, I believe that is the one there. You can see that this was the Terraform that I conduct on. I did a Terraform init and then Terraform apply. Let me go to the beginning of the top here. Okay, 1 second. There it is. That was destroy, wasn't it? That's way too far there. Okay, cool. Perfect. I just used the time binary. Oops. I just used the time binary there just to make sure I can time how long this would take to complete. And here, of course, is the plan before the apply. And then all the way down here, this is the cluster being created. And then, of course, thereafter, that's when we are now installing on that, and we are then generating a kubeconfig file, and then of course it creates the second storage pool. And the apply complete, H was also created, and it pretty much does the automated installation of OnDat. And of course you can see the credentials that we have set earlier on. And of course, here you can either use you can either export the config file, or you can just use your Azure login, Azure CLI tool to be able to get your credentials and just apply them to your .kubeconfig directory instead, which we've already done. And if I do Control-L and do kubectl get pods A, and you can see that we have a cluster that's up and running. But more importantly, let me just hide that and go back. You can see that we've got our clusters. We've got our etcd storage class here, etcd namespace here. Sorry, and then we've got our storage OS components here, which shows us that OnDat is running. And if we do a kubectl nodes, you can see we've got nodes here, and these are the 5 nodes we talked about earlier on. We created a storage node pool, and then the default node pool, that's just a standard node that comes out with a cluster of AKS. The distribution that's running is, I believe, can do a wide. Yeah, it is Ubuntu. Ubuntu is the default distribution for AKS, and there's no need to do any extra configurations here. All you do is deploy on that, and it works out of the box. It has a correct kernel modules available and already loaded, and that is pretty much it. So that's a great thing. You don't need to make further customizations. You can just get started really quickly and work with on that. So as we're going to dive in, first of all, we're going to configure, we're going to create a custom storage class, and we're going to configure on that so that it only uses the storage class. So we're going to go to manifests, unless, and we can see that we've got storage class directory and we've got Strimzy directory. We'll talk about Strimzy later on. We're going to navigate into storage class. All right, and you can see here that we have a V2 storage class on that encryption replication. Topology aware placement, I know that's a bit of a mouthful, but if I do a cat V2, you can see here what we talked about earlier on in my slide, that we can configure encryption. We've set our replication to 2, and we've also set topology awareness to true, so that each volume is placed in a different node. We make sure we enforce that part here. We've also set a failure mode to soft, but that is pretty much it. There wasn't any other further complications, but further configurations going to make. And all we have to do here is do a kubectl apply -f and then v2. It is created. So to inspect that this resource has been created, at sc, we can see that we have the object has been created correctly. So that's great. 8 seconds go. You can see there are other storage classes. This is from Azure. And we can also see one from storage class 2. Whenever we do a deployment, we always automatically install a storage class for you that's available. It doesn't have too many configurations. It doesn't have any configurations. It's just a standard storage class, but you'll be using on that by default. But in this situation, we want to make sure that this we set this as the new default. So I'm going to go back here, and this is also part of the same repository. And the next thing what I want to do here is to mark the default storage class we have right now, which is, I'll show you what it looks like. Unmark that. So this is the default one, but we want to unmark that. All right, if I can, that's look, my browser just being a bit weird. All right, it is perfect, cool. All right, and then you can do kubectl get sc. All right, and then you can see now we don't have any default here. That's fine. But now what we want to do, we want to mark the on that storage class at the one we created early on. So true, and then Control V, and then we can do get sc again, and you can see now we have a new default. So this means that any application, be it Prometheus, be it a database that you're going to create with this cluster, it will always use this by default. And we've already set parameters there that it has to have encryption. It has to have 2 replicas per master volume, and it has to be placed in each volume has to be placed in a different availability zone per node, and this is this allows you to have a full control in terms of making sure that your data is replicated, it's encrypted, and yeah, and that is pretty much it here. So the next part here, we have that configured, and now what we're going to do, we're going to create, we're going to deploy a stateful application, and the stateful application we're going to be working on is Strimzy, so a Kafka essentially. So Strimzy has a operator, a Kubernetes operator of Kafka. Kafka is a messaging queue that is used in a lot of organizations, and here it requires persistent storage for it to function, and we want to make sure that persistent storage is replicated, that it is also encrypted, so nobody able to read the data, and it was also spread evenly between different nodes. So we're gonna just go straight to the quick start, strimzy.io quick start, and we're going to create the namespace. And then I'm going to just navigate. All right, that's fine. Well, that's okay. And we're going to go to applying the streams installation file. So this will deploy the operator that allows us to be able to create a cluster resource for Kafka. Okay. All right, that's the resource being created. And then we're going to do a kubectl get pods namespace Kafka. Right, you can see that our operator is running 0 to 1, but it'll be 1 to 1 soon once it's happy. But meanwhile, we're gonna just navigate to the directory we had earlier on, strimd, and you can see that we have a Kafka persistent single on that YAML /manifest. So now we're going to pretty much create a cluster, a Kafka cluster. And here, I can use this here, but I've made a couple of modifications, which I'll show you just now, so that it will be able to work with OnDat. So I can do a cat Kafka, and you can see that I'll make sure I specify the namespaces under Kafka. And also, you can see the size here is 15 gig, but more importantly, that the storage class that we created early on is being used here. So set on that storage class here, changed from my typo there. It's supposed to be from, not form, 100, but essentially for testing. And that is pretty much it. So it will create one for the cluster, and then it'll create one for Zookeeper too. So do Control L, and so let's do a kubectl get pods Kafka. Right, and okay, so 1 on 1, we are happy now. Everything's good. We're going to do a kubectl apply -f Kafka. Yes, that's correct. And we are going to deploy. Now it's going to take a bit of time for it to stand up. Kubectl get pods pods namespace Kafka, and also watch. So we are waiting for Zookeeper to come up. We're also waiting for the strimd, the Kafka cluster to come up too. I've also written this down here. So meanwhile, whilst we're waiting, I can show you what the output should be looking like. So there you go. So we want to make sure that this is running. The Kafka cluster, the Zookeeper is running too, and then a cluster identity operator too. So let's keep that. All right, so we've got 101 for Zookeeper, and then now Kafka should be up and running soon. Yep, the containers being created. And then we have a running container, and then I believe we have one more pod that needs to be created. I believe this is the one. "27 seconds, so it's still fresh. I'll watch, but I'll wait for that to come. Oh, there it is, pending, and then the container is being created. So I want to make sure that we get 3 out of 3 containers there. Three. Yep, take a bit of time for everything to stand up, but that's okay. As is the first time. 2 out of 3. 3 out of 3. Okay, cool. That's fantastic. So 1 second, please. So the first thing we're going to do now is we're going to see the persistent volumes that have been created. So kubectl get PVC. Let's get PV, and we can see that we've got a Kafka claim. We've also got another claim for my data, but the most interesting part here is that the storage class is being used is the on that encryption replication topology aware placement one that we created earlier on. And that's the same thing also for the cluster 2. If we do kubectl get pvc namespace Kafka, all right, typos everywhere. You can see that we've got 2 PVCs there, and you can see the storage has been used, and the capacity and the access mode that's there, and the age of these claims. So now that's all working and great. What we're going to do is that we want to get some visibility into our cluster. So it's great that we've got this up and running. It's not an issue, but we want to see a bit more details in terms of, okay, where is my replica? And also, how can I manage this, not just from my cluster, but also from a centralized solution too. So what I'm going to do, I'm going to do a port forward, and just create a port, and we are going to do a storage OS, get volumes, namespace, let's do a namespace Kafka. That's incorrect. Just following there. And there you go. And you can see here we've added a bit more information than what we got here instead. So we can see the location of this PVC, but we can also see where it's attached onto, and you can see the replicas that on that created here. And of course, you can see the PVC name too. But if you want to go into more detail, let's go to a describe. If I can spell, describe volumes, and it will describe all the volumes that have been created on that. And you can see the labels that have been attached. As you can remember, the labels that we talked about earlier on, encryption is enabled. We've got beta mode 2, that's a soft. And we've got the replica that is set to 2. And we've got topology awareness also set to true. But the interesting aspect here, we've got one replica that is a master, not one volume that is a master volume here. And you can see it is located under this node. But then we want to see the replicas. You can see it's located on a different node, and the same also on a different node. And this is the tap feature working right now. It's made sure that we've placed each replica on a different node to ensure that we guarantee higher availability. This can be also done the same for the other volume. And you can see that's also the massive volume is also on node 0, and the replicas on 1 and replicas 2. And whenever a node goes down, on that automatically detects this, and will essentially create a new replica. Well, first of all, it will elect an existing replica and then create a new replica. And then afterwards, we make sure that we have, the 2 replicas that we defined to make sure that it is consistent. But the thing is that, you aren't losing any of your data that, that has probably gone down because of a node failure. And that's kind of like the key aspect here is that, you have data that's always running and you don't have to worry if something goes down. And if we go to our UI now, that's great. We've got the CLI, but what about making sure we have a unified view of being able to access not just one AKS cluster. Let's say if you have 20 AKS clusters, and even there maybe you have some which are on premise, or some that are not even AKS, or you have GKE. How do we get a centralized single plane view of all of this? And on that has a SaaS platform that allows you to achieve this in one view. And in this situation, we don't have any clusters here right now, but what we would do, we were going to add a cluster, and we're going to name it AKS on that test. And we're going to go to Azure, as that's the cluster location here. And we're going to create the cluster. But it's just generated us some unique details for allow us to be able to connect our cluster to this portal. And if we copy that, because we've already installed on that. So if you haven't installed on that yet, you can also install it in one go here. But because we already installed on that with Terraform, we just only need to install the portal manager that gives us that link between our AKS cluster and the SaaS platform that on that provides. We're going to just paste there, and we're going to do enter. And that should deploy the operator. That's great. And the storage is configured now. And we're going to finish. And your cluster is ready, operation successful. So let's refresh that page. Okay, no cluster yet. Oh, there it is. All right. Let's view the details of this cluster. And there you go. So we've got our data here. We've also got, it doesn't just show on that information, but also shows other storage, other volumes that are also created here, and also more information about your cluster. And also shows that, the replica status. You can see we have 2 ready. And you can see that, of course, for this one, it's not configured because we didn't use on that as a storage class here. You can view the details. You want to drill in and view the details of this PVC, and you can see replica 0, replica 2, the same information that was being shown here. It can also be shown here too. And it shows the health and if it's promotable. So if a node goes down, we're able to promote any of these replicas to go to be a master. And essentially, yeah, there you go. This information, the labels that we've defined earlier on. And there you go. You can see we've got now 1 cluster, we've got 5 nodes and 5 persistent volumes here. And it also shows you deployed applications in your cluster too. So now this is just 1 cluster, but imagine having 10 or 20. And it's not just Azure. We can also add, different versions here, different cloud providers here. The goal here for on that is to be able to run anywhere and be platform agnostic. So it could be on premise, it could be on AKS, or it could be on AWS or EKS. And that is pretty much it. So there you go. 1 second, please. All right, and cool. So now we can see that we have these persistent volumes that have been created on that. But we talked about it being secure, right? So we want to see, how do we secure this? So we're gonna do kubectl get secrets, namespace Kafka. Cool. And you can see that in this namespace we've got of course the operator secrets, but more importantly we've got storage OS namespace key, storage OS volume key, and these all are important because what on that does quite differently is that we ensure that each volume has its own encryption key. And that means that you can only access the volume with the encryption key that it's assigned to. So this opens up an opportunity that you'll be able to, essentially have a multi-tenancy environment. If you have 1 cluster, but you don't want to make sure the other team that's in namespace A is not able to see namespace B, you're able to ensure that at a data level 2 that it's possible. So as long as they don't have access to those keys. These are Kubernetes secrets. So there isn't anything proprietary about this. But the interesting aspect here is that Kubernetes secrets store secrets in base 64, which essentially is just obfuscation and not really encryption per se. So how do we encrypt secrets, Kubernetes secrets specifically? And this is one thing we've been working on. We thought that, hey, we need to find a way to be able to make sure that these secrets that are going to be created are secure. And you've got the KMS provider that is Trozu, that is an open source project, and it's KMS plugin provider. And what it does, it acts as a middle person between Vault and if your KMS key management service such as Vault, and your Kubernetes cluster, and it makes sure that your secrets are encrypted and are managed through your KMS solution such as Vault. So this essentially makes sure that your secrets cannot be compromised in case your cluster is compromised. So it's okay to defend, but you have to always think about what happens when a cluster has been compromised and to reduce the blast radius. So that's one of the things we've been working on, and you can always check out the project Trozu. right here. Here's the open source KMS profile design. You can also check the repository, Git repo. All right. I'm currently in the hotel room, so internet is a little bit slow at the moment. But I think the demo did go well, so ish. Okay, great. So there you go. And if you want to know more information, then feel free to check out the project if you want to contribute. If you want to just be part of the community, feel free to come. And yeah, and that is pretty much it. So that's the demonstration of being able to deploy on that with Terraform on an AKS cluster. And essentially we're able to deploy Kafka, which is a messaging queue solution that also, of course, managed or created by Strimzy, the operator itself. And of course, we're able to connect our cluster to on that portal. And it's pretty simple. It's through the kubectl plugin, and it just opens up a lot of opportunities for you to be able to see your applications differently and be able to manage your applications, which require persistent storage specifically. And yeah, so if we go all the way to the top, do we have any questions, or we are okay?
Hey, Rodney. I
Hey.
think we've got two questions. One is, can you run database as a service with OnThat and AKS?
Yes, yeah, absolutely. So this is one of those things where this is one of the main goals of OnThat is to be able to run databases that you probably aren't supported in the cloud provider that you're using, or if you're using one of the databases that are cloud native, that are new, but you have to find a way to deploy it and also have the features that you would expect from a managed service provider that does manage database as a service. This is something we do, and this is one of the key use cases here. But yes, let's have a look here in terms of I think cloud native landscape has a list of some of the databases here. So some of them aren't available. For example, if you look at Vitess, it's not available in some of the cloud providers. So if you want to run Vitess in Kubernetes, but you want to make sure that your data is replicable, replicated, sorry, and it is also encrypted, you can do that under OnThat, and also many of the other databases here too that are available. So that's the whole point, and the best part is that you're not only just running one database, you can run as many databases as your Kubernetes cluster supports. So you're not stuck to just one database, and then you have to create another one, which is going to be costing you a lot more money on a long-term basis. So yeah, cool. I think there was a second question, I believe.
Yeah, there's another question, which is, does OnThat support snapshots?
Yeah, that's a good question, actually. So one of the things that OnThat has been working on actually is we've released a beta version of our snapshot feature to make sure that we're able to back up, we're able to work with other backup solutions such as Kasten, and be able to integrate with them, and you'll be able to do snapshots for your applications. So this is at the moment it's in beta version. OnThat 2.8 is going to be released very soon. We're just working on finalizing that. So hopefully by that time it should be production ready. But yes, that is something that we do, and it's an important thing that that I think every storage solution requires. To be able to, you have your application, but also you want to be able to back up the data in case your whole Kubernetes cluster goes down. So you're able to push that data somewhere else and be able to restore pretty quickly. So yeah.
Perfect. Thank you. If you wanted to just go down to your deck to the last slide and pull up the portal link in case anyone wants to sign up to it.
Yeah. Oh, completely forgot about that. Sorry about that. I actually didn't mention that to you all. So yes, the portal. Here's the portal. Bear in mind, if anybody can access this, feel free to sign up. Ondat is free, forever free for 1 terabyte on your cluster, and you can get started and and work with Ondat, and you get the same features that I worked on here today, and explore. And of course, if you're looking to grow as a business or as a team, we have commercial services and commercial sales. You can feel free to reach out to a sales team, and we can talk in terms of more about your use case and what you would like to achieve. And cool. And lastly, we're hiring too. We're a small team, but we are, we're working on hard problems, and we're looking to make storage very, very easy on Kubernetes. Yeah, if you're interested, feel free to reach out to us, and or reach out to us by the booth if you're at KubeCon. So yeah, thank you.
Thanks for joining, everyone.
Cool. Thanks.